Hello everyone, in this video I'm going to talk about solving quadratic equations with real life scenarios. I'm using the trajectory motion of kicking a soccer ball. So here we go. This is a scenario. A soccer player kicks a ball. The height of the ball is modeled by an equation h is equal to negative 5t squared plus 20t. Now, so I can insert a graph of this one. I have no idea why that didn't happen. Anyway, let's try one more time. So the height is equal to, or in other words, I think it needs y equals. So instead of h and t, where h represents the height, remember that, h represents the height, t represents time in seconds. This is seconds and this is in meters. Yeah, so we'll convert that into y equals negative 5 x squared plus 20x. Insert the graph. There we go. I can bring it down a bit here. All right, now, so we are going to do some solving based off of this equation. What is the maximum height of the ball? So the first part is, what is the maximum height? So if you know the features of quadratic equations, your maximum height should be your vertex. That is your maximum. And as you can also see, because the leading coefficient, the term with x squared is negative 5, the curve opens downwards. It's opening downwards. Yeah, and your b is the term with the x, which is nothing but your 20. Now, to find your vertex, the formula vertex for the x coordinate, because your height is represented along the y-axis, so the maximum height I need, the maximum value is going to be minus b divided by 2a. So minus 20 divided by 2 times negative 5. So that would end up as 2. So what is that? What do I interpret from that information, correct? So which means that the time it would take to reach the maximum height, that is the x value. So this is 2 seconds. So this is the x coordinate of the vertex. So it's very important to know that. So I use the formula minus b by 2a. So it took me 2 seconds to get there to the maximum height, but I still didn't get my maximum height. Now you're going to take this value and you're going to substitute into the equation. What is your original equation? We said your h is equal to negative 5 x squared plus, or rather t squared plus 20t. Now that we have the time 2 seconds, I'm going to do h is equal to negative 5 2 squared plus 20 times 2. So now your h is going to be 4 negative 20 plus 40. So the final answer is 20 meters. So the maximum height in 2 seconds, it's going to reach 20 meters. Yeah. Now, the time that it took to get there, we already solved. Yeah. The time that it took to reach there was 2 seconds. So you can, so you can actually write now your vertex as 2, 20. So this is your T and this represents your H. Now, when does the ball, after kicking, the ball has to come back to the ground, right? So at what point will, or how long will it take for the ball to reach ground? So now that is a third question. So when does the ball will land back on earth, or land on the ground? So now in our math world, so when you kick the ball, it's coming back to the ground. So that means the height should be considered as 0. So that means now you're equating your equation, which is 5t square plus 20t to 0. Okay. Now we can factorize this. So I can write this as, I'm going to break it down as much as possible for everybody to learn. This can be negative 5 times t plus 4 times 5 times t equals 0. Now, what are the common terms that you can see? I can see negative 5 t. There's a 5 and a t, so I have to change that to a negative sign in there somehow. I'll do that. Now, if you see, if I take out negative 5t, I still have a t, but this one has to be negative because I'm lagging the commonality of having a negative sign. So I'm making that to a negative, and I'm going to write this as 4 equals to 0. Now you can write this is called something like this. So null factor law, or in other words, you can remember NFL. Yeah, your null means 0. Null factor law. What is my law saying? My law is saying that even if one of the multiple is 0, then you get a 0, which means like 0 times something is still 0, or something times 0 is still 0. So you're developing the idea from there. So that means I'm going to equate two things here. I can say negative 5t to 0 and t minus 4 to 0. So here you'll end up as at t, the ball was at 0 on the ground, ignoring the starting point. We don't want that. And here, if you solve this and you take your negative 4 to the other side, it's becoming positive 4. So in 4 seconds, the ball is again going to hit the ground. So it was at maximum at 2 seconds, and it's coming back to the ground at 0 seconds. Sorry, 4 seconds. 4 seconds it was at the ground, and it's going to hit, it's going to take it 4 more seconds to reach the ground. So there we go, guys. So this is where we are developing our understanding of using quadratic equations, and also graphing your parabolas and having an understanding of what is the maximum point, which represents the height, the maximum height that a person can kick the ball to, and then how long the ball, once it's kicked off, how long it will take to reach the ground. So these are the type of questions that you would come across using quadratic equations.